All right, welcome back. So today we have a question called queue reconstructing by height. So let's just get right into it. So it says, suppose you have a random list of people standing in a queue. Each person is described by a pair of integers, h and k, where h is the height of the person and k is the number of people in front of this person who have a height greater or equal to h. So basically, what they're trying to say is that if the person's too tall, they can't see anyone that's shorter than them. So that doesn't matter, right? So basically, you can only see the people who are your height or taller, and that would be in the k, right? That would be measured in the k. K means how many people in front of you that you can see, and then h is what your height is. So for example, in this input is like 7, 4, 7, 1, blah, blah, blah. So here you can see 5 has 0 because he's right in the front. I mean, this person's right in the front. And then 7 is also 0 because that 7 person does not see 5. Just, too tall. And then 5 sees 2 because 7 and 5 is their height or taller. And then 6 sees only 1 because 6 is taller than 5. So 6 only sees the 7 guy, and then 4 sees all 4 of them, and then 7 is 1, right? So essentially the question is, it's basically about ordering it such that the tall people, honestly, it's ordering it such that the tall people is ordered first, and then the medium people are ordered second. You'll see what I mean. So let me draw this out to make it even easier. So let me draw actual people. So for example, we got big guy over here, okay? So the input would be this, okay? Big guy over here, and then we have a short girl over here, and then another big guy over here, and then a slightly taller guy over here, and then 6, and then another 5, right? So basically this is 7, 0, and then this is 4, 4, this is 7, 1, this is 5, 0, this is 6, 1, and then this is 5, 2. Okay, let's do this bigger. All right, so what we can do actually is essentially, let's just go intuitively. So if we only have the same height, how do we sort them, right? If everyone were the same height, then we would just sort by k. For example, we would see 0 and 1, so we would just sort by the number k. That's very easy, right? Because the higher your number is, it means the more people you see in front of you, and because you're all the same height, we just order by k, right? And then that's one intuition, is if the height is all the same. And then we realize that if we have a shorter person that comes in, for example, 6, 1, then for example, now we have 7, 0 and 7, 1. And then with 6, 1, it really doesn't matter where you put them in terms of affecting the people who are taller. You could put the short people wherever you want, and it won't affect the order that we put for the tall people. The tall people, once we've put them, the order is great. It's already good, and no matter how many short people you put in front of them, the order will still be correct. Because as long as the tall people are ordered correctly, whatever you put in between them, it doesn't mess up their ordering. So the only thing we need to sort is the guy with 6, 1, the shorter guy. So here, what would you do? You would put them in between. Why? Because k is 1, and you know that there's one person in front of you, which is 6, right? So, which is interesting, because imagine if we started the shorter people. If we start with the shorter people, then once we add the big guys, it screws up everything, because you already know how many people are in front of you, but you don't even know the people yet. So the best thing to do is to sort the tallest people first, and then keep adding the next tallest people, and then the next tallest people, so that it doesn't affect the ordering, right? So the algorithm can go like this. What we can do is, so first we order 7, 0 in our queue, 7, 1, right? And then, so we're done this. It's already done. And then now we want to do, actually, I'll keep the same color. Now we want to do the next tallest people. So the next tallest people is 6. So you have 6, 1 to put. Okay, 6, 1. I want to put in between here. Okay, so I'll just put it in between. I didn't think this through. So then now 6, 1. This is correct, and then 7, 1 is still correct here. All right, what are the next tallest people? These guys, right? And then how do we order them? We have to order them at, okay, 5, 0. It means you have to be, like, we could just take this index. That would be just your index of the current queue, because no matter how many shorter people you add, it doesn't really mess up the queue. So what you can do is, and you know that everyone that's taller than you will be included in this K. So 5, you could just put them directly here. 5, 0. Right, because it sees 0 people. And then 2, how many people do we see 2? So as you can see, I think it's a little bit important to order it by height first, from tallest to shortest, and then also by K, from smallest to biggest. Because if we put 5, 2 first, then it might be kind of confusing, because like if we put 5, 2 here, but then we add like here, if we put it here and then we put the 5, 0 in front, it wouldn't be 5, 2 anymore, it should be 5, 3. So we should always add the smallest first, because if you're in front and things change on the back, it does not affect you. So it's this almost the same reasoning as the height. Like if you're tall, then the short people, no matter where they go, it doesn't affect that number. But then if you're looking in front, if you're right in front, then whatever happens in the back doesn't matter, right? Same concept. Those two concepts, we'll put it together and then we'll be able to code it up. So then 5, 2, we'll put it here because that's the second spot, right? And then now we have 5, 2, 5, 2, right? And then 4, I should have spaced them out a little bit better. Yeah, and then what's the next height? Yeah, then it's 4, 4. So we have 4, 4, so 1, 2, 3, and 4, and then we'll put 4, 4 here, which is perfect. Yeah, so now this is perfect because there's 4 people in front of you. Perfect. This guy 7 has 1 person in front of you. This guy, let me use white, right? This guy, and then 4 is like 1, 2, 3, 4, and then 6, 1. Yes, there's this guy in front of you, and then this one was supposed to be 5, 2. Yes, 2 people in front. And then 7, 0, yeah, because you see the horizon, and then 5, 0, you see the horizon. So as you can see in this algorithm, what we did was we sorted the tall people first. Perfect. So let's think about that. We should sort by tall, then short. That's what we want to put first. And then we just do kind of like an insertion sort, right? Because basically what I did here was an insertion sort. I just made sure I put in the right spot. So, but the order matters, which elements. So first we should put the tallest people, and then we should go through from tallest to like the people who have a higher K number. So the people who see most people. So then we just go through like that. And then we just do insertion sort into this new queue. So let's check the code, see how we can write that. Okay, so we have these people. Now the first index, the 0th index, is the height, and then the index 1 is how many people they see in front of them. So we want to sort that, right? What do we want to sort? We want to sort by the height first and then the position, or like how many people they see. So we're going to create a lambda function here just because it's faster, and then it returns like the ordering. So we're going to return a tuple, and then what do we care about? We want the height. So we're going to do negative x0. That means I want the height, but I want to sort it from decreasing. So from the highest to lowest, to the tallest people to the lowest. I want those guys to be first, right? And then if we sort it by height, once we sort by height, we still have to sort by their Ks, which is how many people are in front of them. Okay, cool. And then we'll have the result array, which is just an array. And then we just perform insertion sort, right? So for P and people, what we want to do is we want to insert them at the position K that they see. Remember what I said about the tall people, we should put them in first, because it really doesn't matter, because you can literally just take the index of their K. You could take their K as the index of your new queue, right? Because the tall people, they don't see anyone, right? So you could just put them first as if the queue was new. And then for 6, you could put your, for the height that is like shorter, you could put them as if there are already people in there, which there are. And then you could just use that index as the position that you want to put these people in. So insertion sort, we put P, so that means we put this guy, which is P would be like a person, and it would have a tuple. And we look at what their position is. K means how many people are in front of them. So which is great because this index works perfectly. If there's 0 people in front of them, then it means they're right in the beginning of the array. If there's 5 people in them, then K is 5, so you could just put 5. The reason why this works is because we're starting with the tall people, and then we start with the short people. So once we've already put the tall people, I know that the short people can see the tall people, so that's why we can just insertion sort these guys in this order. And then that's pretty much it. The code is actually extremely easy. The hard part is to figure out how to sort them in a way and insert them in a way such that it works. So yeah, so if we submit this, and yeah, it works perfectly. So that's pretty much it. So what would be the time complexity of this? Well, the time complexity of this, because of the sorting, this takes O of n log n. And then, so sorting is n log n, right? And then insertion sort, yeah, it's kind of like insertion sort. This takes n squared. Why? Because for p in people, that is like a linear thing. So this is like O of n. But then each time we look at a person, we have to do an insertion sort. Insertion sort means you have to go through the whole array and find the exact place you want to put it in. And once you put it in, you have to move the other elements forward, which takes O of n. So this is also O of n. So then O of n times O of n equals basically, so then the time complexity is O of n squared, right? And then in terms of the output array, space complexity, it really depends if you call the result array a extra space. Actually, it is an extra space. So space would be O of n because you have this result array. Awesome. Yeah, so inserting takes O of n, and then because we do that n times, it's n times n, O of n squared. All right, that's pretty much for this question. Thank you for watching, and see you next time.